All right, so welcome back here. Let's continue with the review here. This is actually going to be a pretty short review for section 4.4 that deals with physical and chemical changes. The main thing to know here in this particular section is let's take the definition that we had seen before when we dealt with physical and chemical changes. Remember that what we had said was physical changes dealt with changes of state. And so this here meant that you had a change either from a solid into a liquid, or from a liquid, say, into a gas. And it could go in both directions. You can shift from either one of these. But nonetheless, though, the main principle behind these, as that in any one of these, the identity of the substance did not change. So that was one of the key characteristics of physical changes. On the other hand, chemical changes were slightly different. Here, chemical changes involved changes that were associated with the composition of the actual molecule. So changes to composition. And composition then, what this actually meant was that you were going to wind up getting a slightly different compound. So here you had a new compound or molecule being formed at the very end. And so that's the main thing that occurred there. Because there was a new compound, the identity of the substance was changed. And so this is something that is extremely important. But this is what we had said at the very beginning when we did the intro back in 4.1. What we want to do here is want to take this a little bit further. And we want to make sure that we explain what actually is happening here. So whenever we deal with these types of changes, let me go to make some space here. These types of changes are associated with one other item, and that's the type of force of attractions that are involved. So whenever you engage in a state change, either from a solid to a liquid or to a gas, what you're actually doing here is you're going to be involved with changes that are going to disrupt the intermolecular forces. So intermolecular forces are going to be disrupted. And so those intermolecular forces, as you remember, are going to be things like the London dispersion forces. We'll label those as LDF. We also had the hydrogen bonding. We had dipole-dipole forces occurring here. But essentially what's happening is that molecules, big molecules, are going to be disrupted from one another. So the bonding that occurred between them, that's disrupted. But the molecule itself is still intact. It's still the same molecule overall. On the other hand, when we compare that over to what's going on in the chemical change side here, what's going on here are intramolecular forces that are going to be disrupted. And so because of the intramolecular forces here, these are forces within the molecule itself. So these are going to be bonds between atoms. And so those bonds are the ones that are broken. And when they're broken apart, essentially the composition of that particular molecule, that substance, is no longer the same. And so that allows those atoms to then recombine with other atoms to form new compounds. And that's how we get the identity of substances here. We wind up with new substances or new compounds overall. So this is the main thing that you need to be able to identify in this particular section. And so the questions that you'll see here would be related to whether you can identify whether it's a physical or a chemical change, and also taking it a step further is if you can understand that it's actually the molecule interacting with another molecule that is going to be disrupted. Those are intermolecular forces. And if you can distinguish that from compounds being broken up and disintegrated into its various individual component atoms to form new compounds. And so that there is section 4.4. It's a very quick and small chapter or subsection of the unit. And so join us in the next one when we look at section 4.5 and we look at stoichiometry, where some of the math that we have alluded to here in the previous sections will address that now and next. See you then.